Welcome back to our channel. In today's video, we are going to understand how an RTD sensor is constructed, the internal parts, materials used, and how each component helps measure temperature precisely. If you are an engineering student, instrumentation technician, or someone who just loves learning how sensors work, this video is definitely for you. So, make sure to watch till the end, and don't forget to subscribe and hit the bell icon for more informative videos on sensors and automation. What is an RTD? Before we talk about construction, let's quickly recall what an RTD is. RTD stands for Resistance Temperature Detector. It's a type of temperature sensor that works on a simple principle. When temperature increases, the electrical resistance of the sensing element also increases. That change in resistance is then converted into a temperature reading. The most common RTD elements are PT100 and PT1000, where PT stands for platinum and the numbers represent their resistance at 0 degrees Celsius, 100 ohms and 1000 ohms respectively. Main components of RTD sensor. Let's now explore the internal construction of an RTD sensor step by step. 1. Sensing element. At the heart of the RTD lies the sensing element, usually made of pure platinum wire or thin platinum film. Platinum is used because it offers excellent linear relationship between temperature and resistance, high stability, resistance to corrosion and oxidation. The element can be made into forms. Wire wound type, a fine platinum wire wound around a ceramic or glass core. Thin film type, a platinum film deposited on a ceramic substrate. Wire wound types are more accurate and used for high precision applications, while thin film types are compact and faster in response. Connecting leads. Next, we have the lead wires that connect the sensing element to the external measuring circuit. These leads are usually made of nickel or copper and are insulated to prevent short circuits. RTDs can have 2-wire, 3-wire, or 4-wire configurations. 2-wire, simple but less accurate, affected by lead wire resistance. 3-wire, common in industry, compensates for lead resistance errors. 4-wire, used in laboratories, gives the highest accuracy. Insulating material. To protect the sensing element and prevent electrical contact, it's surrounded by insulating materials like ceramic beads, glass, or mica. This ensures that temperature affects only the sensing element, not the wires or outer case. Sheath or protective tube. Now comes the protective sheath, also called housing or protection tube. This is the outer metallic tube that gives strength and protection to the internal parts. It's usually made of stainless steel, inconel, or other corrosion-resistant materials. The sheath keeps the RTD safe from physical damage, moisture, and chemical reactions in harsh environments. Filling material. Inside the sheath, the empty space is filled with magnesium oxide powder, NGO, or similar material. This filling provides electrical insulation between element and sheath, better heat transfer, mechanical support to prevent vibration damage. Terminals or connector head. At the top end, RTDs have a terminal block or connector head, which helps in connecting the sensor to the measuring device or transmitter. The connector head is often made of aluminum or plastic, and it protects the wiring from dust and moisture. In some designs, RTDs are directly connected through cables with plugs for compact or field applications. Construction types. Depending on design, there are mainly 2 types of RTD constructions. Wire-wound RTD, the platinum wire is wound on a ceramic core and then sealed inside a protective sheath. Very accurate. Ideal for laboratory and precision work. Thin film RTD, a platinum film is deposited on a flat ceramic surface and coated with protective glass. Compact. Quick response. Cost-effective for industrial use. Working principle in brief. Once the RTD is installed, as temperature changes, the resistance of the platinum element changes proportionally. This resistance is then measured by an instrument or transmitter, which converts it into a readable temperature value using calibration formulas or standards like IEC 60751. Summary. Let's quickly summarize the construction of an RTD sensor. Sensing element, platinum wire or thin film. Leads, 2, 3, or 4 wires. Insulation, ceramic or glass. Sheath, stainless steel or inconel. Filling, magnesium oxide, NGO. Connector head for external connections. All these parts together make the RTD accurate, stable, and reliable for industrial temperature measurement. How RTD sensor looks like in real. So that's how an RTD sensor is constructed. It may look simple from the outside, but the precision inside makes it one of the most accurate temperature sensors used today. If you found this explanation helpful, give this video a thumbs up, share it with your friends, and subscribe for more sensor-related videos. Drop your questions or next topic suggestions in the comments below. Thanks for watching, and I'll see you in the next video.